Hello everyone, I'm Brady Volpe, founder of the Volpe firm and Nimble This. Thanks for joining us today. With me is John Downey, consulting network engineer at Cisco Systems. Welcome, John.
Thanks, Brady. Again.
Today we're going to be talking about a number of topics, including DOCSIS Channel Bonding. As always, if you're on Twitter, use the hashtag VolpeFirm to submit questions or submit them directly to the live broadcast by clicking on the Q&A button. Should be in the upper corner of the broadcast itself. And John and I will answer those questions during the broadcast. We do want to let you know that Google creates about a 1-minute buffering delay between a broadcast from what John and I are talking to when you actually see us. So please submit your questions during, while we're talking. As you have a question that comes up, that'll get queued in, and then we can answer those as we see them and as we get time. We'll try to keep this broadcast reasonably short and not try to get on too many tangents. So talking about what's trending right now, everyone's probably getting invitations and announcements about Cable Tech Expos coming up in the fall. Some of us may be getting our emails about the impending deadline this coming Friday, not today, but 1 week from now, that our workshop and presentation papers are due. Mine is also due. I'm going to be presenting at the symposium, which is the Monday right before the expo starts. So I hope that many of you will be able to attend that. I'll be talking about DOCSIS 3.1 and proactive network maintenance. John, are you going to be presenting this year?
No, this is the second year in a row I actually did not submit a paper, so I did about 5 years in a row, workshops, and a symposium, also the very first one, 2 years ago on capacity planning. And then I decided not to submit this year. Just there's so much activity with DOCSIS 3.0 and remote PHY and some cool stuff I'm working on right now. But I did want to submit, I think it's a good idea, and no one submitted that I know of, is how does quality of experience get affected by doing more downstream bonding? If I have gaming and VoIP and telepresence and applications that are latency or jitter sensitive, how does striping that traffic down more downstreams? Like when we did 4 downstreams, maybe not so bad. Now we're going to 8, 16, 24, maybe 32 downstreams. So I could foresee potential issues with low speed flows, like maybe 3, 4, 5 megabits per second. Maybe it's over-the-top video, like Netflix, it's only like 3 or 5 megabits per second. Do I really want to stripe that across all 24 downstreams? Does that add latency or jitter? So it's just, now, actually over-the-top video is not a UDP service, right? It's actually a TCP type of service. It's actually like a file being downloaded and buffered into your PC or your TV set, and then you view it. So that wouldn't actually be as sensitive to jitter and latency as, say, real-time voice. Sure. Or maybe real-time video.
Yeah, so speaking about over-the-top video, there was a very recent announcement that I found interesting about Netflix. And they said that they're going to start offering Ultra HD resolution content for the 4K TV sets. And they're going to start off by offering all 62 episodes of Breaking Bad, which I love that TV show, great TV show. But the impact that so there's the Netflix impact that it's had on DOCSIS networks, because people sitting at home watching Netflix and binge watching TV shows, so hours and hours of this, as you said, HTTP streaming of video. Now we're going to see 4K streaming content coming from Netflix servers over our DOCSIS networks. I think this is going to have an impact. I was curious what your thoughts are that this may have on DOCSIS networks.
It's funny, is like I deal globally with all my customers, and Netflix might not be prevalent yet in some of these countries. I'm like, just wait. We've seen in North America when it's been implemented, Google, Netflix, Hulu TV, over-the-top video. The interesting thing about over-the-top video is, like I said, it's not UDP based, it's TCP based. So we found that this downstream traffic, even though it might only be 3 to 5 megabits per second, it's creating upstream traffic in the form of acknowledgments. Now, when I do really high downstream speeds, DOCSIS 3.0 modems usually, by default, have something on called ACK suppression. So the acknowledgements get suppressed, so I don't have as much traffic on the upstream, which is great. But the over-the-top video really isn't that fast. It's 3 to 5 megabits per second, maybe a little bit more. On to your subject, it's definitely going to be even more when we go 4K. We might be going from MPEG 2 to MPEG 4, but now we're doing even better compression for the over-the-top. For 4K, I think of H261 or something like that, a different codec or a different compression. But even if we compress it in half, the content is more than double resolution, if you will. So it'll be interesting. I don't know what the final numbers are, but you know, the 4 meg service on downstream could jump to double. It could be 8 meg, and the 7 meg could jump to 15 meg. Now that higher downstream is going to require higher upstream acknowledgements. And ACK suppression usually doesn't work that well when you're below, say, 10 or 15 megabits per second on the downstream, because the ACK suppression or the ACKs aren't really that high in speed. It might only be 200K or something. So I don't want to rely on this little feature to unclog my upstream pipes of acknowledgements, if you will. I guess the moral of the story is the more downstream content I have and the content that gets higher and higher and more, it's creating more upstream capacity issues as well. So I definitely have to do ATDMA and upstream bonding and things like that. But going to the 4K, it will be interesting. I mean, I always said that our capacity could be fine right now, but all it takes is one new application to throw everything out. You know, now all of a sudden, oh man, what if I do Slingbox, and Slingbox has this new application that allows me to do multiple addresses instead of unicast one-to-one.
Right.
You understand? Like,
yeah.
I can have a Slingbox, and my brother wants to watch the World Cup coming from my TV, so my upstream is like loaded because he's downloading my upstream.
Yeah, and I think, you know, a lot of people have been holding off on the 4K TVs because there has not been content out there, and now Netflix is saying we have content for the 4K TVs, so we're going to see those coming. And so this is a warning for everyone: beware. There's going to be a new Netflix 2.0 effect coming out. So with that, we have cable operators that are offering higher and high tier services. There's a also in the news, a certain cable operator has announced, you know, we hear a lot of this, but there's a specific one that said they're offering 300 megabit per second tier service in their market. Of note, though, they discussed their 107 megabit per second downstream service, with which includes a 5 megabit per second upstream service. And this caught my eye because, John, you and I have always discussed the 10-to-1 rule, and they're violating this by a factor of 2, because they should have, if they have 100 megabit per second down, they should have 10 megabit per second up to follow that 10-to-1 rule. And I just want to get your thoughts on that.
So the reason 10-to-1 rule comes in is downstream TCP windowing is typically 50-to-1 ratio, 50-to-1, which is not so bad. So I'll typically see the upstream of 2 megabits per second of upstream acknowledgements. So I still have to have some upstream capacity for real services besides just supporting my downstream service. I still need upstream capacity, right, for whatever, sending PowerPoint files or whatever you're doing at home. So we usually say 10-to-1 ratio, easy, simple math. And now that we're getting higher tiers in the downstream, some people are kind of bringing that down to a 20-to-1. 20-to-1 is still fine. So 100 by 5 would mean 100 meg of downstream TCP is going to eat up potentially 2 meg of upstream if ACK suppression is not working, but I still have 3 meg left for real upstream traffic, you know, other services. So a 20-to-1 ratio is fine, but 10-to-1 ratio is easier math. And so typically that's what we're always going for. And I can understand, you know, when I was doing 10 by 1, not so bad. 20 by 2, not so bad. 50 by 5, not so bad. But 100 by 10, 10 meg upstream is a lot of upstream. So maybe when we start hitting these higher downstream speeds, maybe some people will start dropping to a 20 by 1 ratio, you know, 20-to-1.
Sure. So we're talking about crazy speeds, you know, from what we had years and years ago with DOCSIS, with channel bonding. So, you know, we have 30 megabits per second, 50, 100, 300 megabits per second in a downstream. Another feature that we often have is it's called by many names, but Power Boost is one of the most common names for it, where for the first second or 2 or 3 seconds you have a higher speed in the downstream than what you're actually provisioned for, and customers really like that because it makes them feel like they're actually getting more speed than what they've actually been provisioned for. When you're getting, say, 50, 100, 300 megabits per second in the downstream, does power boost still make sense? What's the impact on the network? Do we still do power boost? What do you say on that? What are your recommendations?
Power Boost was trademark name from Comcast, and Cox kind of get in there too, and a lot of people use the same trademark name of Power Boost, and that's allowing it's manipulating how DOCSIS works, how DOCSIS does rate limiting. It's saying let a modem do all these bytes with whatever pipe is available until those bytes are finished, like my tokens are used up, and then rate limit that modem back down to its max rate. So Power Boost, for all intent and purposes, is really a perception is reality. You're giving the customer the perception of higher speed, and the only way they're testing that high speed is doing speedtest.net or some type of Ookla server. So to get the most out of Power Boost, we need to make sure our max burst in the CM file is big enough to make the test last long enough for whatever speed test site they go to. And most of the times, it's maybe a 10-second test. It's not the speed test locations, those companies that offer speed test sites, they got a little bit smarter about Power Boost. They used to just download a certain file, and if it was 2 seconds, the Power Boost was longer than that, so you thought you were getting 100 and some megabits per second, even though if you watch the speedometer, it would go up and then come back down. Basically, that was Power Boost. My feeling was Power Boost was great for the median tiers, 5 meg down, 10 meg down, 15 meg down. Let them Power Boost up to one channel capacity of 35, 36, 37 meg, and then come back down to 5, 10, 15, whatever. But I also, on the other hand, I've seen where when we configure the CM file max rate, we usually configure 10% over what we sell it in the marketplace. So say this customer you talked about was going to offer, what did you say, 107?
Yes, 107.
100. So they say 107, but I bet you the CM file is configured for like 115. Because it might actually, 117. A lot of people will configure their CM file 10% over what they say. Because when you go to a speed test site, it reports at layer 3 and above. It doesn't include the layer 2 overhead, which is the Ethernet layer. While the CM file and the CMTS are adding in 18 bytes on every Ethernet frame. So
so for listeners, I mean, these bytes that you're talking about, it's like the MAC address, the IP address. It's sort of overhead information versus what the actual subscriber is transmitting, which would be their web browsing and stuff like that.
Yeah. So my point is, if that customer wanted to sell 107, they configured the CM, the cable modem for 107, and the customer went to a speed test site and did a speed test, they'd never see 107.
Right.
They might see 104. Because if you subtract 18 bytes off of every Ethernet frame, that's subtracted out of their reporting on the customer side. On the CMTS side, that's not true. So we might see exactly 107 from the CMTS perspective. But the end customer, that's what counts, he's only seeing 104. So a lot of times, my customers will configure 10% over. So here's my dilemma. When I configure 10 meg down at 11, no big deal. 20 meg down at 22, no big deal. 50 down at 55, not so bad. But 100 meg down, configured for 110, you just configured 10 megabits per second over just to satisfy this layer 2 versus layer 3 difference of reporting, but that customer is getting that full 110 all the time. Maybe I could use Power Boost to fake this out a little bit. Maybe I would take a 100 meg service, configure for 105 with a Power Boost to say 120. That way, when he goes to a speed test site, he still sees higher than what he's paying for. He's paying for 100. It bursts up 120. His reporting might say 115. Power Boost for 10 seconds comes back down, but it comes back down to my 105, which in reality is probably more like 100 anyway. So sure. I can sort of see Power Boost maybe satisfying a little niche here on the really high end, like 300 meg. maybe I configure 310 with a 330 power boost. Do you understand?
Yeah, yeah, and although if we think about it, 330, that 30 megabits per second that's like an entire QAM channel that we're dedicating
Yeah.
to it. So we have to, I mean, we
Yeah.
really have to understand the ramifications of 30 megabits per second when we're talking 300 megabits per second. So it's a lot of data. It's a lot of it's a QAM, almost a QAM channel in a downstream.
Yep. 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 So I think power boost still has a play here, and also you can do power boost on the upstream as well. A lot of people don't realize that. You can make, there's two settings in the CM file on the upstream called max concat burst and max traffic burst. Max concat burst will let you do more concatenation in the upstream, get better per modem upstream speed from a 2.0 modem. Upstream concatenation doesn't come in play with a 3.0 modem because it does something called CCF, continuous concatenation fragmentation. So that doesn't come into play. But the other field, max traffic burst, if I set that to say 2 or 3 megabytes, then the upstream can do an upstream power boost till those megabytes are done, and then it will come back down to the max rate you set. So there are cases where I could do a power boost on the upstream as well.
Sure. So while we're talking about the upstream, John, I'd like to talk about some frequency spectrum issues associated with channel bonding, and on upstream in particular, I get asked quite frequently, can you put upstream bonded channels side by side, or even channels in general in the upstream side by side, or do they have to have some sort of spacing, maybe 10 kilohertz or 20 kilohertz spaced apart?
So that comes up with me also, and then people are like, they have to be contiguous. I'm like, well, from 5 to 42, if you do 4 channels at 6.4 megahertz apiece, they're pretty much contiguous anyway because there's not enough spectrum. So once you do 4 or 5 upstream channels all that wide, you pretty much put them side by side. The only reason why I might separate 2 channels and not put them butted against each other would be if I'm still doing upstream sweeping. So if I want to insert upstream sweep points in between my channels, I might do 200 kilohertz in between my channels.
Right.
But I don't have to. I can put 2 6.4 megahertz channels exactly 6.4 megahertz apart, center frequency to center frequency.
Yeah, so they're
so
side
that
by
would be
side
butted against each other. They're
right,
side by side. The only other reason I might separate 2 channels is to eliminate or avoid CB and 10-meter handband. So I might want to avoid, say, 26.7 to 27.3, whatever CB is. Most people say CB is at 27, but it's really a little bit wider than that, right? It's 40 channels that can kind of bounce around in there. And 10-meter handband is at 28. So a lot of times I might avoid that, kind of an ounce of prevention is worth a pound of cure type of deal. I know my CMTS has ingress cancellation, so it'll cancel it anyway, but maybe I want to have some reserve in my ingress cancellation for other ingress, not for something I know that's going to pop in my network all the time anyway, if I do have CB or ham radio popping in there. So I might avoid it just to stay away from it.
Right. Good recommendation.
So I've had customers, might use 38 megahertz as the highest center frequency, but for 40 megahertz roll-off, that's, now you're relying on pre-equalization to make up for your roll-off.
Right, which we've covered in previous hangouts. So if you're curious about pre-EQ, please watch some of our previous hangouts on those. And so, John, before we leave the upstream, we do have a question from one of our listeners on the upstream. What is the best approach to mitigate packet loss and reduce SNR caused by OBI in the RFOG environment when bonding upstreams?
So OBI is optical beat interference. That's when in an RFOG, RF over glass environment, some people call it DPON as well, DOCSIS over a passive optical network, or call it whatever you want. Because DPON, I used to not even like that terminology, because that makes it sound like it's DOCSIS over an EPON, GPON. And RFOG is not that. RFOG is an HFC plant where it's a lot of fiber and the only coax is in the house. So it's still HFC, right? Hybrid fiber coax. It's an analog optical link or amplitude modulated optical link. It's not digital. And the biggest difference between a typical HFC plant and an RFOG plant is on the upstream, you only have one laser that's always on, regardless if RF is feeding it, the laser's always lasing, if you will, back to the optical receiver, 1-to-1. But in an RFOG environment, you could have 32 lasers coming back through a 32-way splitter combiner, optical splitter combiner, to one optical receiver in the head end. You can't have 32 lasers all at, you would think, 1310 nanometers of same wavelength. They would interfere with each other, so you have optical bead interference. Well, the RFOG spec says, let's do 1550 nanometer down. Let's reserve 1310 nanometer up for EPON, GPON, and they're using 1610 nanometer on the upstream for the RFOG. So you have 1610, and depending if the optical link is amplitude modulated or frequency modulated, because there's two different types of modulation techniques. On the optical link, when you do frequency modulation, it has its pros and cons. One is distance. It's actually a good thing. Frequency modulation is not as bad on a certain distance. Amplitude modulation, more distance, means attenuation, so your amplitude drops on your signal and now you can't go as far. And think about it, as 32-way optical splitter combiner, you lose, if you do 10 times the log of 32, you lose close to 18 dB just on the splitter combiner, not even in the fiber loss yet. So you don't want a laser to have to be a 2 milliwatt laser or whatever from the home. It costs more money. So you do all the math, blah, 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 and you say, all right, how do I keep these lasers from interfering with each other? Well, you have to make sure the modems only come on one at a time. So if you have a DOCSIS 2.0 modem in your house, and I have a DOCSIS 2.0 modem in my house, but you're an upstream 0 and I'm an upstream 1, that's two different lasers could come on at the same time because each upstream has its own scheduling in the CMTS. So the way Cisco came around or worked around this, we have a special command in our CMTS, it's called DPON, cable upstream DPON, that will force all legacy modems to upstream 0, one scheduler. But DOCSIS 3.0 modems can bond all four because we know it's a 3.0 modem, and we know once all upstreams are bonded or traffic sent on upstreams, we know just that house is coming on at that specific instant in time. I don't know if I explained too much here. We could have a Google Hangout just on RFOG, right?
Yeah, we could. But I mean, you talked about cable upstream DPON. That covers for 2.0 modems. Does that also cover for bonded 3.0 modems, where you could have two upstreams, three or four upstreams? I think that's a particular troublesome issue with respect to RFOG when with the bonded upstreams that can cause OBI issues.
For this to work properly, if you use 4 upstreams for bonding, then you have to have one 4-channel upstream bonding group. You don't want to make two 2-channel bonding groups in the 4-channel, because if a modem at your house does 2-channel and my modem does the other 2-channel, now you're back into the same case of the legacy modems where 2 lasers can come on at the same time.
Okay, so the recommendation here would be, if you're doing upstream channel bonding, that they have to all be in the same bonding group. Okay. Yes. So I think we've probably covered it here. If it's a Cisco, you have to have the cable upstream DPON on, and all the modems that are in that group have to be in the same bonding group, and that's what's going to.
Then you might say, well, what about legacy set-top boxes? They're not even timed for DOCSIS.
Yeah, that's a real problem.
They can come on anytime they want. So that's going to make a laser come on.
And you're going to have OBI issues.
It looks for energy. Yeah, it looks for energy. I don't care if it's CB, noise, or a legacy set-top box, the laser will turn on when it sees that.
Yeah.
So it's going to turn on, and now all of a sudden you have OBI.
Yep, it's problematic.
So my recommendation for RFOG, if you're going to do an RFOG environment, you're installing basically a little node at everybody's house, why would you give them a 2.0 modem? And why would you still be stuck with legacy set-top box?
Yep.
Either go DSG, go full DOCSIS 3.0, and get rid of 2.0 and legacy devices.
Yeah, so if you're going to go RFOG, go big or go home.
That's it. There we go. My new mantra.
All right, so let's move on to downstream bonding, and I think we'll just cover the same topic, just frequency recommendations, about general what you do, best practices for frequency in the downstream bonding.
So this one's an interesting one because the lowest frequency you can use for DOCSIS 3.0 is 111 megahertz center frequency. That puts you a bandage of 108. I've seen people put 4 channels down there, and it was fine. And the attenuation of coax is less at low frequencies, so it worked out well too, right? And then they're like, oh, we need to turn on 4 more downstream channels, but our spectrum is full with all the digital video and analog video, so we're going to put 4 channels at the other end of the spectrum. 4 on the low end, 4 on the high end. Now all of a sudden, we have to make something called RCC templates, so an 8x4 modem knows how to tune all 8 channels properly. We also know that in a real cable plant, when you look at frequency and levels, if I have 4 channels at one end, let me see if I can see myself, 4 channels at the other end, this doesn't, which one is it? This one? There we go. And I separate them further apart, in a real cable plant, the levels might look like this. Make sure I'm showing the window. You understand?
Yeah, that's tilt.
Yes. So if the channels are contiguous, the tilt's going to be minimal because they're contiguous, right? Because there's only 16 channels. 6 times 6 megahertz times 16 is only 96 megahertz. It's not that much tilt in 96 megahertz. But if you separate the channels apart by 500 megahertz, all bets are off. Does that affect my bonding? So I talked to Broadcom about this, by the way, and they said, we are comfortable with 10 dB of tilt between the RF channels and still be able to bond. I'm like, all right, that's a good understanding. My problem with separating the frequencies is DOCSIS 2.0. If I do load balancing between these frequencies and 2.0 modem moves from 111 megahertz to 555 megahertz, the levels could be off by 12 dB. DOCSIS 2.0 DCC Technique 4 is probably not going to survive. The modem will move, it'll re-register, it might stay on that frequency because it's still a legal level, but the jump from 10 dB delta, that's not going to stay online. So my DOCSIS dynamic load balancing is going to be hampered. It's going to be detrimental to my load balance, if you will. So, I mean, keep it simple, stupid, right? Keep the frequencies contiguous, side by side. If you do go to 1 gigahertz on your cable plant, maybe anything above 860, you make sure you understand 2.0 modems don't tune above 860, so you make sure your load balance groups aren't including frequencies above 860, because then the 2.0 modems could be told to move a frequency you can't even tune to. So it's just some little nuances and things to think about. And also downstream spectrum, for your cable plant and you can look up fcc.gov to find out where 4G is allowed to transmit, you know, cell phones. Right. And it's not just off air.
700 megahertz band is
it could be this, the CPE, your handheld sitting right next to my modem. When this transmits, it's getting into my modem. It might not be from the cell tower affecting me as much as my handset in my house affecting me. So 4G can legally transmit between, what, 750 and 900 megahertz, somewhere in that range.
Yep.
And then off-air digital broadcasters, Fox, ABC, CBS, NBC, they are broadcasting digitally at different frequencies in different cable plants. And you should know what that is and maybe stay away from it.
Yeah, so I've seen, I've had one of my clients recently with a lot of voice over IP issues, and they had ingress. Of course, if you have ingress, you oftentimes have egress, so they could be impacting the voice providers, the 3G, 4G providers as well, but they're in the process of moving their DOCSIS channels from the 700 megahertz frequency spectrum, the downstreams, to lower channels, and what they're seeing better results with their voice service, their voice over IP service, because they had the ingress coming in. They're finding out it does not impact their video quite as much because there's more interleaving in the video than what you have with DOCSIS.
Yeah. You know, the other interesting thing is when we turn on more QAM channels in the head end, the power per channel goes down, the max power, right? Part of DERFI, the DOCSIS radio frequency interface spec for DOCSIS 3.0. So if I have 4 channels coming out of a connector for an edge QAM, then the spec says 60 is 1, 56 is 2, and 52 is 4. That's the spec, right?
Yes.
And then it drops to, I think, 48 or 49. So it's not 4 dB every time you double it. Sometimes it's 3, sometimes it's 4, if I look at the spec. So when I go from 4 to 8, it drops again by 3 or 4 to 49. I go to 16 channels coming out of that edge QAM connector, it drops to like 45 dBmV. So One, my level's already lower when I turn on more qualms coming out of the connector, but if the frequencies are high, what do you think is going to happen in the cable plant in the head end? Your splitters and combiners have more loss at higher frequencies as well. A splitter combiner could look, you might say 3.5 dB. Yeah, but in reality, it could be 5 dB of loss at 1 gig. I mean, just look at the spec. No one's trying to hide anything from you.
Yeah.
You know, a splitter is not going to be 3.01 dB like theory says.
Yep.
So it's just something else to think about is if I use higher frequencies, more attenuation, more loss.
Yeah. There's always lots of opportunities in cable and DOCSIS, so it keeps all of us employed. So, well, John, we've covered a lot of ground today. When you go out and get your 4K TV, please pick up a second one for me. I'm looking forward to rewatching Breaking Bad in 4K and driving some traffic over the internet. Thanks for your time today. We covered a lot of ground. We've not gotten. I think we've covered all of our questions. So I think we're good.
We didn't cover any resiliency or partial mode. That's the only thing we didn't cover was resiliency.
We were going to cover that, but we'll leave that for another partial mode and impaired. We'll leave that for another time because that's been a topic lately. But we're at the half point in the hour, so we're going to call it a wrap. So thanks, John, and we'll talk to you later. Take care.
No problem. All right.
Thanks everyone for attending. Bye-bye.
All right. Bye.